use of ampacities calculated from Annex B of the National Electrical Code for feeders that do not meet the requirements for main power feeders is a topic of discussion. Firstly, a comparison of ampacities. The calculations demonstrate that the ampacities calculated using Annex B with appropriate temperature adjustments are higher than those specified in Table 310.16 for general feeders. This difference is attributed to the calculation methods used in Annex B, which consider factors such as conductor spacing and bundle geometry. Secondly, the rationale for conservative ampacities. Table 310.16 ampacities were developed based on historical data and experience. They are intentionally conservative to account for factors such as aging, insulation deterioration, and potential overloads. Benefits of using Annex B ampacities include more accurate estimates of actual conductor ampacity potential for using smaller conductors for the same load requirements, and reduced voltage drop and power losses. However, there are cautions and considerations. Using Annex B ampacities may not be code compliant for feeders that do not meet the definition of main power feeders. The conservative ampacities in Table 310.16 provide an additional margin of safety that may be compromised if using Annex B ampacities. Ensure that downstream equipment such as circuit breakers and disconnects are rated for the higher ampacity calculated from Annex B. Annex B ampacities are based on specific conductor spacing requirements. Proper installation and maintenance are necessary to maintain these spacings. The decision of whether to use Annex B ampacities for feeders that do not meet the requirements for main power feeders should be made on a case-by-case basis, considering the specific circumstances and the following factors: code compliance, safety concerns, equipment ratings, conductor spacing, and potential benefits. It is recommended to consult with a qualified electrical professional before using Annex B ampacities for such applications. Understanding the conservative nature of Table 310.16 is crucial. These ampacities provide a buffer against various factors that can affect conductor performance over time. For example, insulation can degrade due to heat cycling, exposure to chemicals, or physical stress. Overloads, even if infrequent, can also contribute to conductor heating and degradation. The conservative ampacities help ensure that conductors operate within safe temperature limits, even under these adverse conditions. The more detailed calculations in Annex B allow for a more precise determination of ampacity under specific conditions. These calculations take into account factors such as the thermal resistance of the conductor insulation, the surrounding environment, and the proximity of other conductors. This can result in higher ampacities compared to Table 310.16, especially when conductors are installed in free air or with adequate spacing. When considering the use of Annex B ampacities, it is important to verify that the installation meets all the requirements specified in the annex. This includes conductor spacing, bundling arrangements, and ambient temperature conditions. Any deviations from these requirements could invalidate the Annex B ampacities and potentially lead to overheating or other problems. For example, if conductors are bundled together without adequate spacing, the heat generated by each conductor can increase the overall temperature, reducing the ampacity. Similarly, if the ambient temperature exceeds the values used in the Annex B calculations, the ampacity must be derated accordingly. In addition to conductor ampacity, it is also important to consider the ampacity of other components in the electrical system, such as circuit breakers, fuses, and terminals. These components must be rated to handle the increased current that may result from using Annex B ampacities. For example, if a conductor is rated for 110 amps based on Annex B, the circuit breaker protecting that conductor must also be rated for at least 110 amps. Failure to properly size these components could lead to overloads or short circuits. When evaluating the potential benefits of using Annex B ampacities, it is important to consider the cost savings associated with using smaller conductors. Smaller conductors are typically less expensive than larger conductors, and they may also be easier to install. However, it is important to weigh these cost savings against the potential risks associated with using less conservative ampacities. For example, If the electrical system is subjected to frequent overloads or high ambient temperatures, it may be prudent to use the more conservative ampacities in Table 310.16, even if it means using larger conductors. The decision to use Annex B ampacity should be based on a thorough engineering analysis that considers all relevant factors. This analysis should be performed by a qualified electrical professional who is familiar with the NEC and the principles of electrical design. The analysis should also take into account the specific requirements of the application and the potential risks associated with using less conservative ampacities. Furthermore, proper documentation is essential. All calculations and assumptions used to determine the Annex B ampacity should be documented and kept on file. This documentation should be available for review by inspectors or other qualified individuals. The documentation should also include a detailed explanation of why Annex B ampacities were chosen over the more conservative ampacities in Table 310.16. In some cases, the use of Annex B ampacities may require special permission from the local electrical inspector. It is important to consult with the inspector before using Annex B ampacities to ensure that the installation will be compliant with all applicable codes and regulations. The inspector may have specific requirements or concerns that need to be addressed before granting approval. The NEC provides guidance on when it is appropriate to use Annex B ampacities. For example, Section 310.15b6 allows for the use of Annex B ampacities for service conductors and main power feeders in dwelling units subject to certain limitations. However, this section does not apply to other types of feeders, such as those supplying branch circuits or individual pieces of equipment. In these cases, the use of Annex B ampacities may be more difficult to justify. When considering the use of Annex B ampacities, it is also important to consider the long-term performance of the electrical system. Conductors that are operated at or near the maximum ampacity may experience accelerated aging and degradation. This can lead to increased maintenance costs and a reduced lifespan for the electrical system. Therefore, it may be prudent to use the more conservative ampacities in Table 310.16, even if it means using larger conductors to ensure the long-term reliability of the system. In addition to the factors mentioned above, it is also important to consider the impact of harmonics on conductor ampacity. Harmonics are non-sinusoidal currents and voltages that can be present in electrical systems due to nonlinear loads, such as electronic equipment and adjustable speed drives. Harmonics can increase the heating of conductors, reducing their ampacity. Therefore, if harmonics are present in the electrical system, it may be necessary to direct the conductor ampacity accordingly. The NEC provides guidance on how to direct conductors for harmonics. In summary, the decision of whether to use Annex B ampacities for feeders that do not meet the requirements for main power feeders is a complex one that requires careful consideration of all relevant factors. It is important to consult with a qualified electrical professional before making this decision to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that the conservative ampacities in Table 310.16 provide an additional margin of safety that may be compromised if using Annex B ampacities. Always prioritize safety when designing and installing electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before making any decisions about electrical installations. Remember to consider the specific requirements of the application and the potential risks associated with using less conservative ampacities. Proper documentation is essential. All calculations and assumptions used to determine the Annex B ampacity should be documented and kept on file. This documentation should be available for review by inspectors or other qualified individuals. Before using Annex B ampacities, ensure that the installation will be compliant with all applicable codes and regulations. Consider the long-term performance of the electrical system. Conductors that are operated at or near their maximum ampacity may experience accelerated aging and degradation. Also consider the impact of harmonics on conductor ampacity. Harmonics are non-sinusoidal currents and voltages that can be present in electrical systems due to nonlinear loads. Using Annex B requires strict adherence to conductor spacing and bundling requirements as outlined in the Annex. Deviations can invalidate the ampacity calculations. All electrical components, including circuit breakers and fuses, must be rated to handle the higher currents calculated from Annex B.